Welcome back. Hey everyone, John here, senior software engineer with over 10 years of experience, lead maintainer of the open source Latterly.io, the one and only. And today, continuing the Leetcode Marathon. Let me share my screen. So we are working on the Latterly kata, which you can see here, and we just recently completed course schedule at the end of the last stream. We used a DFS implementation. So I'm going to pick back up on course schedule. I'm going to do two things. One, try a topological BFS solution, and then two, try to recall the DFS solution. So the implementation originally was not successful. We had to time box it and look up the answer. So I took a break. I'm going to do a topological BFS solution as a distractor and also practice in its own right, but then to come back and try to reinforce the DFS. And then we'll continue with course schedule 2, path sum, binary, tree level order traversal, word search. And so to forecast the anticipated time for the remainder of this Leetcode kata, which goes through question 12, I think a best case is 30 minutes a problem and a worst case is an hour a problem. So in the worst case, 1, 2, 3, 4, 5, 6. Woo. In the worst case, 6 hours. The good news, I guess, is it's not yet 5 p.m. So we can get done by midnight. Let's go. I do expect a minimum of 2 more streams, so I don't think that this will be the final stream. So I think there's going to be a minimum of 2, and there might be a third. One other sort of caveat before we dive in, maybe 2 more. After these problems, if we get done pretty early, then I may dive into Leetcode. Who knows how many problems we can get to, just fill up the remaining time. Probably go for the easies first. That's one thing to call out. The other thing to call out is that in the previous stream, TikTok was not presenting chat messages to me. And I took a chancy measure to try to enable chat messages this time around. I removed the comment filtering. So comment filtering is intended to prevent like mean messages. But my theory is that TikTok could have been overly aggressively filtering comments, resulting in me not being able to see any of them. So I just removed the filtering. Now the TikTok stream that I've just kicked off told me failed to stream, just outright errored, failed to stream. And then I can see that it is in fact streaming and people are joining. So something strange is going on with TikTok Studio. First time using the studio, maybe it's just a piece of mediocre software. But do drop a comment if you're on TikTok, and that will help me see if it's gonna work this time around. So I see we have a few people over there already. I'd appreciate likes and comments on any platform, but particularly on TikTok. The reason for that, once again, is that the last stream, I was unable to view TikTok messages, and the solution there was you can check the link on my bio and drop a comment in YouTube or Twitch. You can access those links from my bio and I'll be able to see those messages. Okay, I think that is all of the preparatory notes. Let's dive in. Let's dive into course schedule, number 7. Course schedule pulled up here. Let me wipe the previous solution. Okay. And the problem reads, there are a total of num courses that you have to take labeled from 0 to num courses minus 1. You're given an array of prerequisites where the prerequisite for A sub I is B sub I. There's an example in the pair 0, 1. So if you want to take course 0, you have to first take course 1. And we return a Boolean. We return true if you're able to finish all the courses, otherwise false. When would you not be able to take these courses? The example would be example 2. So you cannot concurrently enroll. There's irreducible complexity. There's a cycle, dependency cycle. To take 1, I need to take 0, and to take 0, I need to take 1. And again, this course schedule problem does not permit concurrent enrollment. And so that is why this would be insoluble. Okay, so it's a bit of a cycle detection problem. It's going to be a bit of a tree traversal problem. And so intuitively, I want to merge my dependencies. So prerequisites is a flat array. We are given that all the pairs of prerequisites are unique, so I don't need to worry about getting 0, 1 multiple times, for example. So it is a flat array, so I'd like to merge them so that I can know all of the dependencies on, say, course 3. It might have multiple dependencies that will be represented as multiple records and prerequisites. So I want to merge them, and then what? Then what do I do? There's a couple solutions from there. The BFS solution would be that I use a queue, and I initialize it with something. What do I initialize it with? Some parent node. The problem with the parent node approach is that we are not guaranteed that there is a singular tree. We're not guaranteed that there's a singular tree or a singular root node. There could be many roots. Okay. The root in this tree would be those courses with dependencies on others that they themselves have no dependency. So there could be a bunch of these. Still, we can seed a queue rather than seeding it with some root node. We'll seed it with those courses where the prerequisites have been solved. And we can basically create a list of courses that you can take in topological order. And if that list is the length of all the courses you need to take, then that means you can finish it. That means you can finish it because it's possible to take a topological ordering. The other thing you could do is a DFS where you just loop through the courses you need to take, and for each one of them, you drill in and you say, okay, this depends on that, and then you drill in and you say that depends on that. And if you drill down this tree of dependencies, do you ever terminate? If the answer is yes, in all cases, then it's possible to take some set of courses. There's no cycle. Okay, so in this case, we want to do topological BFS. And so what will be the complexities? So strategy is topo BFS. We need a queue, which will take ON mem in the worst case. We must explore every node in the worst case. So also ON. And the time and space complexity would be unchanged if we used a DFS approach. Oogly booglies. Did I see on TikTok that you landed a job recently? I did get a job offer. Actually, I got a couple job offers, but that doesn't mean the job search is over. I still have upcoming FANG loops for which I'm preparing. So yes, I have gotten a couple job offers. I got my first job offer within 3 weeks of being laid off. It's definitely possible in this market. Don't let anyone tell you, getting a job is impossible or these other downer, naysayer, depressing things. It's just not true. There are proven strategies. Check out latterly.io, join the Discord, follow the step-by-step checklist to help you learn to code and land a job. And if you need help, that's why there's a community. Don't feel bad about needing help. One of the biggest pitfalls that I see is people want to try to go it alone and prove how cool they are, and then they whine about how they haven't gotten a job in a year. Well, social networking is critical to getting an interview. So use the community. There's hundreds of people there on the Latterly Discord that would love to work with you. Okay. So we're going to use topological BFS. We need a queue. And so let's dive in. We'll eventually return length of topo sorted is equal to num courses. Okay, so we need topo sorted, which is going to be empty. And we need a BFS queue. And let's label this differently. What am I going to put here? I'm going to put those where the dependencies are already satisfied. I'm going to say satisfied courses. And I'll put a comment. It's a BFS Q. Oogly Booglies says, congrats either way. Thank you. Thank you so much. And so it's here to do process queue. And then up here to do calc, or like merge depths and calc in degrees. I think this is pretty much what we need. So satisfied courses, we can just leave it like that. I could write a lambda expression if I can remember the syntax, but I can't, so we'll do this. So I will say for course in, let's see, this would be a course IDX. For course IDX in degrees. For in range. We'll use the range of the in degrees. If course IDX in degrees is 0, then we will put it in our queue. Okay. And I will say while satisfied courses. While length satisfied courses. I think I can just say while satisfied courses, but I'll go off the length. It makes me feel better. Feels a little bit safer than relying on the falsifiability of an empty list in your language of choice. Here we're in Python, but I think it's clearer to the language agnostic reader when I check the length explicitly. So here's to do. DQ is completing the course. Decrement depths. In Q, descendant if in degrees now 0. Okay, that's what we're going to do when we say process queue. That's basically what we're going to do, 3 steps. Let's merge dependencies and calculate the in degrees before we continue. Thank you for the follow on TikTok. If you're on TikTok, do you mind dropping a comment? I'll be curious to see if I can read them this time around. Thank you for the likes and for the follow. So what I'd like to do is I could use the num courses range or the prerequisites. Yeah, I want to use the prerequisites. For prereq and prerequisites. So what I want to do here is I want to make a merged dictionary, and then scene is for memoization, which I will need in DFS. I don't think I need it in BFS, but I'll put a marker there just in case. Okay, so merged. So prereq, it's always going to be a length of 2. And so there's the blocked course, and then there's the blocker course. So prereq index 1 is the blocker, and the blocked course is prereq index 0. This could be a default dict. I'm not going to do that just because I'm forgetting the syntax. So here I will say if if merged dot get. So the keys will be the courses and the values will be the dependencies. So if blocked, all right? If it's there, then merged dot get blocked add. So it's going to be a set. And we will add blocker. Else we will initialize the set blocker. So new set is a set, new set dot add blocker, and then merged the blocked key of merged is the new set. And you can see what we mean by merged now, right? If I have 0, 1, 0, 2, 0, 3, they're now going to be collapsed to key of 0, set of 1, 2, 3 is the value. Okay? So now we've merged it. What about our n degrees? What about our n degrees? It will be a parallel structure. So n degrees of blocked now becomes 1. And in this case, n degrees of blocked is incremented. Let's use the parallel syntax just to make it clearer. Okay, now I know my degrees. And so here's satisfied courses. In degrees, there's the course IDX as intended, yep. And if the n degrees is 0, for this course, 4 in range n degrees. Now the range on n degrees might not be right. What I'd like to do is 4 in range known courses, I think. 4 in range known courses. So we're looking at all these courses that I need to take, 0, 1, 2, 3. And if that course has no dependencies, we will add it to satisfied courses. Okay? And as long as there are satisfied courses, we're going to process them. Good. So let's say cur course is satisfied courses dot, what is it, pop? Pop or shift? Can I pop 0? I want to DQ the first course. DQ first course. In JavaScript, that's shift. I think I pop 0 in Python, if I'm not mistaken. Okay, and so now what do I want to do? What I want to do is decrement the n degrees of the dependent courses. So how do I know who are the dependent courses? The way that I know that is through merged. Is that right? I might have the inverse. I might have the inverse of what I need. So I say, I depend on this many other people. Now, how do I go tell them that I'm done? I can loop through all of them. Let's just try to loop through all of them. I don't think this is right to do. I'm not sure if this is right. We'll say for course and merged. I'll say if that other course, if current course is in the dependencies of that other course. And I'll even call this foreign key course to show that it's like a different course. Let's say other course. Push or append. I guess it's append. Let's see. If in degrees course IDX is 0, if in degrees course IDX. Oh, right. So this could just be if it's not, I can rewrite this if it's not in the n degrees. Course is not defined. Okay. List doesn't have append with 1p. Okay. So this was right in the case that has a loop. What about in this other case? Let's print. If this one has 0, that indicates a bug in my satisfied courses logic. Yeah. So I have a bug in my topo, in my while loop. I have a bug in my while loop. So in degrees rightly has a single key value pair, 1, 0. Init satisfied courses. Okay, this could be the issue, is that it's 0 is falsy. That could be the issue. So my current course is 0. Current course in merged other course. Let's see if I get there. I should get there. I do get there. Okay, I do get there. Then the n degrees of the other course should be decrement of the 0. So it's 1 before the decrement, which is expected. And we do get to this place where we append the other course. So Howdy is here with 1, so we append 1. Oh, I've never appended to my topo sorted, that's the problem. Okay. Topo sorted. So if this is the case, do that right up here, right? Cool. Did that work? By golly, he did it. I was not sure that I was going to get that. Topological BFS. Woo. He might know something. Not sure if this is right. Let's review that. Why was I not sure that this is right? Because it doesn't seem very efficient. That's the reason. So I'm scanning every other course every time. I'm scanning every other course every time. I wonder if I can delete out of merged, and if that would make it more efficient. So let's go over here. Let's actually delete. Dictionary changed size during iteration. So this looks like n squared, doesn't it? So for every course, I have to check every other course. Okay, instead of deleting out of here, what can I do? I can have another structure. If it's in merged, and not in completed, that would just be satisfied courses, and not in satisfied courses. So can I make satisfied courses a set? Whew, I don't know. Pop takes no arguments. Wow. So satisfied courses can be a set instead of a list. So I think this should be faster. Looks really slow. The runtime is really far down the list. Oh, let me get rid of my print statements. I can extract this. No, I can't do that. It doesn't look like super fast, does it? Beats 5%. It's not really a flex. But anyway, I have the topologically sorted list now. And here I'm dequeuing satisfied courses. I think I need two different structures here to process, because I don't want to purge out of satisfied courses. So I will dequeue to process, and I will not dequeue satisfied courses. Nope, that doesn't make sense. Why is one an empty set? Satisfied courses, add, to process, add. Oh, because I'm using while, yeah. Because of my while loop. Okay. And that's not notably faster. Wow. Okay, well, I guess you can just check them all every time. Doesn't really seem efficient, but we didn't gain much through the optimization. Or maybe that's just the way the test cases are. All right, let's try to do the DFS approach. Let me remove the two process thing. Okay, and I can look at my submissions. I can grab a link to this one, and I'll have that under the top of VFS. So we've got a few links here. I haven't canonized my favorite solution yet. Okay, great. I'm not going to go through the problem statement again. It's the same problem. Now we want to do this with a DFS. And the problem that I ran into last time, I can mark that my DFS is in process with a primitive. I can do that. But if the primitive is falsy, I should look at the key presence rather than the value. That's the problem, because the falsy value is throwing me off. And so what I want to do here is check every element. So O, N, time complexity. Use DFS with memoization. So O, N, space complexity. And what I'll do here is to do merge prereqs. And then return true if we survive DFS. And then call DFS. So that's it. So we'll eventually return true. Okay. And when I call DFS, I will for course IDX in range num courses. For course in range num courses. I think that's right. And I want to self.dfs on that course. Then we'll also send merged and seen. Do we need anything else? I think that's it. We need the course index, we need the merged prerequisites, and we need a map of nodes already seen, or like values already seen. I think this is right. Thank you so much for the likes. Okay. So yeah, 2 steps remaining. Let's implement DFS. And then merge the prerequisites. So here this gets a self argument, it gets these. So here we'll say for prereq in prerequisites. Ooh, spelling. Here I want merged is a dictionary and I want seen is a dictionary. Okay. And what do I want to do for each of these? There's the blocked and the blocker. That's what these records indicate. So the blocked course is pre-rec index 0, and the blocker is pre-rec index 1. Okay. I want to say if above elif. No, I don't. I want to say if it's the autopilot taking over. I want to say if my coffee is not empty, then drink. Death to the autopilot. Blocked is 0 of prereq. What I want to know is, do I have a set there? Do I have a set there? And if not, let's make it. So if blocked and merged, then we will merged. The blocked index of merged, and we will add the blocker. So we're merging right here. Else, merged, the blocked index is a new set. In the new set, we need to add a blocker, and we also need to create the new set. Great. So now we merged our prerequisites. Thank you for the follow. Yeah, I'm not seeing comments on TikTok again. I don't know if anyone's put any. I just tried to do a test comment myself. I don't know if that went through either. Bummer. If you're on TikTok, by the way, you can go to the link in my bio and join YouTube or Twitch stream, and you'll be able to post a comment there. You can also sign up at latterly.io and join the Discord where you can ask anything you want. I've had a few joiners today. So for course IDX and range, I call DFS on all of them. Here I want to get the result of the DFS. If the result is false, then I want to return false. Otherwise, keep going. So this should generate a Boolean. No, that's kind of tricky. It's like the equivalent of a promise, but I don't want to deal with that. Okay, so it either returns a Boolean or a function that would then return a Boolean. So what I want to do, first of all, is guard. So if we've already seen this thing, if course IDX end scene, and this is where I messed up last time because I tried to use the get, and the get was returning the falsy marker. So instead I'm doing a key check. If the course IDX is in scene, then we'll just return that value, the scene value. But if it's not been seen, we want to immediately mark that it's in process. You can mark it with pretty much anything you want. I'm going to mark it by defensively assuming that the courses cannot be solved. The courses cannot be scheduled until we prove that they can be scheduled later. So then we want to recurse, and then if we make it this far, it will be true at this point, and then we can return true. So how do we recurse? We will look at the dependencies. How do I know the dependencies? For dep and merged. Instead of passing down the course IDX, I want to pass down dep, which is an index. That's the dependency course index. It's about what I expect. Let's see if it works. So for dep and merged, Yep, I'm missing a guard. You might have no dependencies at all. So here's my guard. We only need to do that if you have dependencies. If you have no dependencies, pass go, collect $200. So in the case where their courses are schedulable, we pass. In the case where they're not, we failed. So what's going on around here? We said true and we shouldn't have. This res, I don't do anything with it. So if this is false, we want to return false. Yeah. Hey. Good deal. Good deal. So we got DFS down. Let's cook. Let's not stop cooking, eh? Course schedule 1 is down. Let's go on to course schedule 2. And the problem reads, there are a total of num courses that you must take labeled 0 to num courses minus 1. You're given the prereq array where the index of prerequisites indicates some course A is dependent on some course B. We want to return the ordering of courses you should take to finish all courses. If there are many valid answers, return any of them. So it's essentially the same problem, but we don't return a bool, we return a topologically ordered list. I could just implement topo BFS once again. I'm curious if I can do a topological DFS. I haven't actually tried that. I'm going to emulate what I would do in an interview setting, which is that I would do the safe option. So intuition, I believe I can do a topological BFS. I may also be able to do DFS, but less sure. So going with BFS. This requires a queue. So O in space complexity. We must inspect every course. So O in time complexity. Okay. And so what will I do? To do merge depths. After I merge the depths, I want to init queue from 0 in degree courses. Process queue and return topo sorted. And that one doesn't even need to be pseudocode. We can literally apply it. So let's literally apply it, and now we can create that list. And here I'll say while there are satisfied courses. Per completed course, satisfied courses dot pop. So here we're assuming that we have some satisfied courses. We're kind of working backwards from the result. So I know what I want to return, and we're sort of working backwards. I laid out the pseudocode structure, and I'm working backwards through the implementation. You can do whatever is easier for you, top down or bottom up. Going from middle out is really weird. Don't do that. You're going to confuse your interviewer. Even if it's intuitive for you, just don't do it. It might have been intuitive to go, oh, okay, let me do the while loop and then build out satisfied courses and then come back. I would have confused the interviewer. So it's, let's complete the while block and then move up. You can jump around if you run into a blocker. If I find that my while loop is non-implementable, then I can go make a structure above if needed. But it's better, I think, to stub the structure above rather than to do the whole implementation, so that you're consistently going bottom up or up down instead of like just jumping all over the place. Okay, so I have my current completed course. Then I need to check all other courses. I need to check all other courses. For course in merged, okay. If current completed course if the current completed course is in the like remote dependencies, then the remote in degree will be decremented. And if those in degrees are now 0, we want to enqueue. We want to enqueue. Not only do we want to enqueue for processing, but we want to add it to the top of sorted list. Okay, so we're taking these courses in a particular order. I think it looks good. Okay, so we've processed these satisfied courses, but what is a satisfied course? It's a course where the in degrees are 0. So we want a 4 in range on the num courses. And this will be just checking all of our courses. And we'll say if in degrees are 0, append to satisfied courses. Okay, that's the pseudocode. If you run out of time during your interview, it is better to have a correct pseudo-coded solution than an incomplete implementation. So do what you can. Do what you can. We are going to want merged, which is a map, and we are going to want in degrees, which is also a dictionary. C-H-A-H-I-J-K. Let's alphabetize these. Okay. Satisfied courses can be a set. So we just literally add it. You can add the course index here. And we can literally use the structure called in degrees. That's all we're doing. We're not doing a bunch of manipulation here. We're scanning through the courses. And if that course index is already satisfied before we did any work, It's just satisfied from the jump. It's initialized without dependency. In that case, I want to enqueue it. It's going to seed my satisfied courses. And the prompt says that there could be many answers and you can return any of them. So the ordering of these doesn't actually matter. I can shuffle them around if I want to. I could flip it. I could put that thing down, flip it, and reverse it. Shout out Messy. But we'll just leave it as processed currently. No additional operations. Save a little bit of cycle. Plus, sorting could cost n log n, which could be constraining in this case. So it's actually better to not sort it from a time complexity perspective. This is looking good. So what remains? What remains is I actually need to calculate my n degrees and merge steps. So here, I will say for prereq in prerequisites. There's the blocker and there's the blocked. So blocked is going to be prereq 0, and the blocker is going to be the first index. Okay. So here we'll have a merged dictionary of sets. We'll have a merged dictionary of sets. And I will say if blocked is in merged, then we will add it. We will add the blocker. Blocked, add blocker. Blocked will be the key, merged will be the main structure. Otherwise, it will be a new set. The new set is in fact a set, and the new set must add the blocker. Right, and I can check that it's 0. The other way that I can do this is I can say if not there at all. If it's not there at all. Okay, we have an error somewhere. So if the current completed course is in merged, I did not calculate my n degrees properly. Okay, so we say that merged now has a blocker. Then we should also say that it has a count of dependencies. That's really the thing we're doing here. And we will increment it in the other case. Set has no object append. Okay, let's add. Great. I wonder if you need an n degrees structure at all. That's a wrong answer. That stinks. I wonder if you need an n degrees structure at all, or if you can just repeatedly use the length operator on the dependency set. You might not need it at all, but it only improves your, it's not going to improve your asymptotic space complexity, will it? So what's wrong here? What's wrong here is that my output is 2 and it expected an empty set, right? So I have always returned the best attempt, if you will. I've always returned the best attempt, but that's not what it asked for. It didn't ask for the best attempt. It said, give me the correct list or an empty list. And so what I want to do right here is I want to return top was sorted if it has all the courses we want. Else, an empty set. Nice. Look at how bad that runtime is. Ew, yuck. It must be possible to do a DFS, eh? I guess the topo DFS is possible. Otherwise, like, why big slow? Why big slow? I'd love to explore that further, but we are on a marathon. We are on a marathon. Let me go to, I think that was the first time I submitted this, by the way, like ever. But we already knew the approach, didn't we? Because it's similar to the pattern applied from course schedule 1. So this is going to be a topo BFS. I guess topo DFS will work, but I haven't tried. I'll submit that just so that I have a submission where the note is present. That's the point of submitting again. Let's get a dub in the chat, eh? Dub in the chat. Thank you so much. Throw some likes on it. And let's keep on cooking. So we did course schedule 2. Let's do path sum. Whew. It's supposed to be easy. Sure hope so. Given the root node of a binary tree and an integer target sum, return true if the tree has a root to leaf path, such that adding up all the values. Is this a backtracking problem? It doesn't say backtracking. Ugh. Such that adding up all the values along the path equals a target sum. A leaf is a node with no children. Here's an example, 5, 4, 11, 2. And so we can just enqueue like all of the attempts. In this case, you could use BFS or DFS, like you could do either one, but I think DFS is more intuitive because of the solution. The solution is like a full slice of the tree. And DFS will allow you to explore a full slice of the tree. So it allows you to potentially, in the best case, return much earlier. Where BFS, you're going to be slowing down your best case performance. You may not be slowing down your worst case performance, right? You may not be slowing down the worst case, and it may not make much of a difference on average, but you're going to be improving your best case performance. So I think that's a reason to do that. Here's another reason. The complexities are going to be equivalent, and DFS is often more concise to write. So intuition, I think BFS plus DFS both work, but DFS best case performance is better, and I think it's more concise to write. So using that. Time complexity is O n in the worst case. Mem complexity. I'll be wanting to use memoization for sure. I don't want to go down this tree like over and over and over. Will be O(n) with memoization. This isn't right. This isn't right. Oh, I'm given a binary tree. So then I think it's right. If you had a tree with variable edges coming out of a node, it could be 2, 3, 4, 5, 6. I think you would need to account for that in the time complexity. But given that it's fixed at 2, then I think we're on the right path. Over a dozen followers on TikTok, thank you for being here. If you're a recent joiner, I cannot read the comments in TikTok currently. That's really unfortunate, and I'm not sure why. But if you go over to YouTube or Twitch, the link is in my bio. You'll be able to drop a comment there. You can also go to latterly.io, which is also in my bio. You can sign up free. You can join the Discord. And you can bring your question there either during the stream or after the stream. I'll be able to get to it. If you're on another platform, we have half a dozen people on other platforms. Thank you for being here. I appreciate your attendance and participation as well. YouTube, Twitch, I can see your comments, so feel free to drop a comment if you have a question or comment. And please give it a thumbs up and a like so that the algorithm will send it around so other people can learn too. Okay, so there are the time complexities. So the approach I would like to take is basically DFS. Now I want to return a Boolean, is that right? Yeah, I want to return a Boolean. So I think I can just return self.dfs. If there's a root. Now what if there's not a root? Because you see on line 8, it's optional. So if it's not a root, I'm glad they included this example because my question was going to be, if there's no root, does that give you a target sum of 0? Since the tree is empty, there are no root to leaf paths. Cool. Glad they have that example there. Okay, so let's return self.dfs if root, else false. Excuse me. My body is slowly decaying. Let me have more caffeine. That will surely fix the problem. Okay. Cold brew at 5:45 p.m. Let's go. Who needs sleep? Let's go. So here we'll define a DFS. And this will take a self. It's on the solution class, so we need a self argument in Python. It will have some intermediary root. We can call it root. It's more like an intermediary root. That's fine. I wonder if I need a separate DFS helper at all. Maybe I could just return has path sum. Ooh. That's exactly what I should be doing because I will want to decrement it. I will want to decrement it on my current value. Let's leave it as a helper. I might collapse it later. So what am I passing to DFS? Target sum. So let's say I'm on the node 5. I'm on the node with a value of 5. What if it has no children? What if it's a node with no children? If I'm a node, is that an example as well? If I'm node 5 and the target is 5, I should return true, I think. That's what I'll be going with and I'll propose. So in a real interview situation, when there's ambiguity, solve by proposal rather than by request. So I will propose to my interviewer that if there is a single node, I will constitute that as a root to leaf path. Now, if they want to push back, that's fine, we'll pivot, but that's the approach I'm going with. Darren, welcome in, good to see you. Darren says, I just got some caffeine and good work. Let's go. Let's go, welcome, welcome. Okay, so DFS, we have the self root and the target sum. And so from here, I want to check the descendants and I want to decrement my current value. I also want to escape under 2 conditions. If I've already seen, and if my current value is the, just call me Dio. Oh man. Is everybody gonna know? All right, y'all, it's Dio. Say hi to Dio. If you don't know who he is, that's your problem. I guess everybody knows now. Cat's out of the bag. Okay. So what I want to do now is I want to adjust for my target. So the root value, it's called root.val. We can see in that tree node up at the top. So if root.val minus target sum is 0, then I want to return true. Then I want to return true. I found it. You know what? That's a lie. I need to know if I'm on a leaf. Because this could be a, like if I have 5, 4, 11, 2, and what's the target sum? 22? But what if my target sum is 20? You see, that would be returning true on the 11 node, but that's illegal. I need to go all the way down to the leaf. So I need to know if I'm at a leaf. I need to know if I'm at a leaf. So how do I know if I'm is leaf? The way I know that is because I have no left and I have no right. The catfish profile pic. It is what it is. They have those AI things, you know. You can try one of those. Root left and not root dot right. It's hard to get a good picture, honestly. I mean, for me anyway. Maybe that's a personal problem. Those AI things kind of slap. Shoulder bugging. Okay, so it's a leaf if there's not a left node, if there's not a left node and there's not a right node. All right. So if is leaf and cur target. Let's see. This is the condition. It wasn't too far away from what we did. If it is a leaf node and the root value minus the target sum is 0, then we return true. Else what do we do? Else, we want to return DFS on left and DFS on right. If either one of them is true. If either one of my children has a path sum, then I do have a path sum. Does that make sense? Okay, so here I can say root.left or root.right. And one thing that I can do here is if not root, return false. Just to make the implementation easier so I don't have to check if left, if right. I'll just eagerly pass you down, and if you're null, then you will guard against that. Okay, so in this case, I don't need this ternary anymore. I don't need this ternary anymore because I'm guarding the same way. So I can just do this. But I don't want to pass self. Self comes in as an argument, but you don't propagate it. Okay? So I just say return left or right. Return left or right. Good. So here I can pass in my root, and let's step through with example 1. So if it's not a root, but it is a root, it is a root. Okay? That shouldn't say root, that should say node. Because you're not going to be a root and be a leaf at the same time. You know, you might in the case of a one node tree. It's still confusing, I'll just call it a node. If there's not a node, we'll return false. But in the case of 5, there is a node. So is it a leaf? It's not a leaf. It's not a leaf. And so what do? I go down here, and I don't want to look for that same target sum. I want to decrement by my current value. Target sum minus the root val. I think that's about it. Come on, computer, what am I missing? Tell me what I did wrong. I have no memorization. That's my problem. Look how long this is taking. So I need to somehow give IDs to these nodes. That's tricky. How can I give IDs to these nodes? Well, a node, a node is its own class, and classes are hashable by default in Python. So I can just literally make a scene map. So let's pass down scene. So if we've already seen the node, return whatever was the result over there. Otherwise, now we are going to say that I've seen it. How do I say that I've seen it? I guess I can just use a primitive. We'll see. Do the key check. Don't look up the value. Oh, we want to say that it's seen, that it has been seen. We might just be wanting to use a set instead of a dict. Let's go for this. I don't know if that helps much. Takes 3 positional arguments before we're given. Root is not defined because we renamed it to be node. Okay. DFS is not defined because it's self.dfs. Oh, well, there you go. How much did scene help us, I wonder? So here, the runtime beat 80%. Let's go again. Beat 60. We're going to get a range. Beat 98. Woof. Woof. Hot and bothered over here. So 60 to 100%. We beat 60 to 100%. Now, if I drop scene, I'm expecting so the memory is low. It only beat 27. If I drop scene, I'm expecting my memory improves and my runtime goes down. Yeah, now we're down to beats 8%, but the memory is beats 72%. Okay. And there's beats 95% on memory. So really, you can choose if you want to optimize for space or performance. And this kind of looks like a better deal. So if I don't memoize, is it still O of N? You got to look at all the nodes anyway. What is it saving me? It's saving me. It's saving me. It's saving me O of N. I'm confused by that complexity analysis. Maybe it's an ON versus O2N sort of thing. ON. No, it should be reducing it from N squared to N. It should be reducing N squared to N with memoization. So I definitely need the memoization. Let's try using a set. The node is already in scene. What am I returning? I don't know that it's saving me anything. I don't know that it's saving me anything. If the node is in scene, you return true or false like it doesn't matter. I guess I can return false because this is not ever going to be the leaf node. This is not ever going to be the leaf node. Why is my runtime not being faster? I don't know. Kind of seems like I got lucky. All right. Well, let me do that one more time. Beat 76%. Kind of seems like that 98 earlier was luck. Anyway, this seems fine. Yeah, we just say, hey, for every node, if the right child or the left child has a path sum, then the parent child has a path sum. You just decrement as you go along. Sounds good to me. So now we are on to path sum 2. And the problem reads, given the root of a binary tree and an integer target sum, return all root to leaf paths. So not just one, you want to return all of them. Where the sum, and you want to return the path, not just a true false. You want to return all the paths. Where the sum of the node values in the path equals target sum. Each path should be returned as a list of the node values, not references. Cool. So 5, 4, 11, 2. 5, 4, 11, 2 is going to add to 22. Makes sense? We definitely want some sort of memoization in this case so that I can backtrack to wherever I was and I don't have to recompute the whole. You can do this as a try. That seems rough. So I don't just want to know that I've seen a node, but I want to know the ordered history. So the set thing is not going to cut it here. All right, well, intuitively, I need to explore every DFS branch. And that's going to be true for BFS as well. So you got O(n)(). Is it guaranteed to be binary? So there's a left and a right. There's not variable edges. So then it'll be time O(n)² mem O(n)². Intuition, I need to explore every DFS limb, branch, lineage, whatever you want to call it. So O(n), time complexity, BFS would be the same. I want to memoize to avoid rework. So space complexity is O(n). BFS would have the same space complexity. I'll choose DFS, hoping recursion syntax is more concise. So let's return Can I do a list of sets? No, because I might have 11, 11. So I need a list of lists. So I'll return self.dfs if, let's do a result. So I'll say result is self.dfs. Whew. And then I'll return result if length of result, else an empty list. That doesn't matter, does it? I can just return an empty list. I'm going to leave it like this because my concern is what if I have a list of empty lists that will appear truthy? I need some way to filter out the falsy elements. I'll just call this filtered. So I may come back and deal with that filtering, but depending on my implementation, I might not need to do any filtering. So I'll not give that too much attention right now. So let's make DFS. And how does DFS work? I'm going to pass it root and target sum and scene. Scene is going to be a dictionary. dict over set to preserve lineage. So I have self node, target sum, and scene. What I want to say is I want to say if node in scene. That is the actual node. That is not just the lineage. It's the actual node. The node has been seen. I think that's fine. I think that's appropriate. I might need like a parent lineage. So we're guarding if it's already been seen so we can escape our DFS. And now what I want to do is I want to say, hey, I have seen this node. And here's how it looks. It looks like a parent lineage, like a cur lineage. How do I make a copy of this thing? I'm not sure. I'm going to run to the restroom real quick. I'll be back. Test, test. Now you can hear me, I think, Kaush. What a bummer. Some setting automatically switched. I wonder how long that was off for. What a total bummer. Well, thank you for letting me know. Hopefully it's better now. Thanks everyone on TikTok. 284 likes. If you're enjoying the video, give it some more likes. Okay, so to do make sure leftmost node, I think it is, but we'll leave that to do. So now what do I want to do? I want to get the current node's children, and they are going to be left and right. They're going to be left and right. You could, in general, get like however many children there are, but we'll go left to right. Yes, we can hear you now. Thank you. Thank you, Kaush. Thanks for letting me know. Oh, that's weird. In example 1, the output is 3, 9, 20. So it's not a flat output. 9, 20, 15, 7. Okay, that's where the difficulty comes in. So it wants them grouped by level. It wants them grouped by level. That's why this is tricky. I was wondering, like, what is tricky about this? What am I not getting? Okay. So I think I do need to track the row depth then. I'll refactor it if I need to. Let me take another minute to see if I can go with this current approach. So I have a queue. And my current node cannot exhaustively guarantee the level. So I will never know the level value in the context of a current node. So how do I know? I can complete a row. That would be the shortest circuit check possible. Okay. Or I can accumulate just the whole tree and as just a second pass, return the groups. In the worst case, the time complexity will be equivalent between row stops and tree stops. In the best case, row stops would be more efficient. Well, let's go with the tree level stops. So it'll just be a whole pass, whole second pass on the tree. So we have a queue. We're going to run the BFS queue. I think it could even be a DFS queue. Not super sure that it matters. We'll run BFS though. So if I run BFS, I'm building a level. I'm building level groupings, and I can do that by index or by, I could use a hash map. I could use a list or a hash map. Why not use a list since that's the return structure anyway? Yeah, that's the return structure anyway. So we will get through the whole tree, and then we will return level order list. Still seems okay. The structure still seems okay. I just need to change the way I'm appending to the change the way I'm appending here. So level order list, I might need to add a new row. So I need to know my current level. So I could do tuples. My queue could have tuples instead of nodes. Let's try that. So here I'll do a root and I'll do level, is this level 0 or level 1? I guess it doesn't matter. So this will be level 0. So while length queue, we have current node, current level. Okay, so if the level order list has this index, then we will append it. Else, we will initialize a new list. And then we will enqueue not merely the left, but the left with cur level +1. And not merely the right, but cur level +1. Okay. Is that the only difference required? I think so. I feel like I'm still missing something. But maybe not. Maybe that's it. So we go through our whole queue. Let's step through with some test cases. That's what we should do. So I have a test case of 3. So 3 goes in. It's at level 0. Then 9 is added. Then 20 is added. They're going to be put onto the index of 1, 0, 1, 9, 20. So 9 first has no children. 20 then has 15, 7. They will be put on the second level, 15, 7. Good. Okay. Example 2 is not particularly illuminating. Neither is 1. Let's see. Index out of range. Right. So the current level is 0. if current level is equal to the level order list minus 1. So in the 0 level, can I do get on an array? That would be let's stick with the links thing. So if I want to look at the 0 index, my length needs to be 1. So if the current level plus 1 is the length, then we'll go directly there and append to it. Otherwise, I need to create a new list. I think that works. List assignment to the index out of range. So when is this out of range? Oh, I can just append. None type has no attribute left. Fair enough. Well, why am I here at all if kernode is none? Wow. Is not valid for the expected return type list integer. Because I'm appending the node and it wants the values. Okay. How was it appended, this naked 20 and 15? Oh, right. That's a mistake. So this should say like that. Nice. We can make it. Go team. We can make it. We can do anything we put our mind to, eh? All right, let's get some likes in the chat. So that was cool. It was not that difficult. I think my main problem was the feeling that I was missing something fundamental. It's like, why is this a medium? This seems too easy. What if I do this without the 0 there? It's wrong, right? We need to do the 0. That's a fun fact. So that we can pop the leftmost node. We'll get rid of the note saying that I don't know why I need to track. I think this is pretty good. Beat 71, beat 79. So tuples here work pretty well. Cool. Let's keep on going. Last one, word search. Let's go. This will be the last of the Leetcode kata, and then we'll get into Neetcode. I think it will be good to have a pause. I might pause at any time. I might need to break for dinner. So we might come back to finish word search. We'll see. Oh, actually, I am being summoned right now. So that'll wrap for now. When we come back, we will do word search and then get into Neetcode.